Alright, so it's me and we're back again. We went through a pretty long journey through why I believe this to be the baseline tetrahedral platonic twisty puzzle solid, as it fulfills the criteria of being a face turner, that it has every piece that's involved in the, that it's a platonic solid, that it's a face turner, that it's the baseline puzzle along which all the other high order puzzles are reduced to. Anything less than that would just be a pocket version, and that there are no trivial pieces. Everything contributes to the scramble and contributes to the solve. Okay, so we get to the next layer that they call the 1, 2, 3, 4, the 4 layer, which is really a 5 layer kind of in disguise, where they did away with these centers, but they didn't do away with this. So the question at first was, what is the cubic version of this? The modification, does that exist? And the answer is it does. Did you guys get it? It was the Skewb. The Skewb, piece per piece, is the exact cubic version of this, if you were to modify that. So you've got some sides that are like this. This represents this cut over here. And you can see it's exactly the same pieces. This is why I like puzzles to be black and stickered, because you can see them a lot better. This just might look like a block of monochromatic colors. Anyway, so this is the center. You've got an edge. You've got an edge here. You've got a corner here. Edge, corner, edge. So this piece is exactly like that. However, this turn over here is actually exactly like this. So with this, you have 4 centers. You've got 2 edges, and you've got this corner and 4 corners. So that's the exact match to this, where they have different turns that have different coordinations. You'd think it was a hybrid. It's actually not. It's not a Skewb hybrid, a Skewb Dino hybrid. I know that's how it was presented first. It's actually a 4-layer tetrahedral mod. So I'm going to do a solve of both of these, because I think the original one, I'm going to use the perspective of this being a modification of a tetrahedron. Now I might as well use this opportunity to go over the algorithm. Now it's the same algorithm that we've used in our face turning octahedron, same that we've been using in our master Skewb. So basically what this does is this is going to take this edge piece, it's going to exchange this to here, and this to here. And what this is you're kind of breaking the symmetry over here. So you're going to go up in this slice layer here, then go down, down, up, then go down, and reverse what you just did, down, up, up. So what you find is this went to here, this went to here, and this went to here. So just to practice again, we go up, down, down, up, down, down, up, up. So same thing. Now one final one we'll take this red and yellow and bring it to here. This blue and red will end up here. This green and yellow will end up here. So up, down, down, up, down, down, up, up. Okay. So anyway, bear that in mind, and you might get a situation like this. So let's go ahead and scramble it up first. And I think you'll find that all of these puzzles that I'm now defining as modifications of these baseline tetrahedral puzzles will make the solve simpler, easier, and a little less cumbersome. Maybe even faster. I don't know. I haven't actually timed myself, but we'll see. Okay. Now what I might do, rather than just do it one, do a step with one and do another step with another, that might be a little distracting, especially if you have this puzzle and you just want to learn how to solve it, because this is now mass produced. Okay, so pretty good scramble here. Maybe I can do a little better. Maybe I can do much better. It's hard to get a complete scramble when there's such limitations with a number of ways you can move it. Okay, so so there's that. Let's do the Skewb. We'll start doing all these kind of moves. This is the mass-produced version. Really well put together. Very stable puzzle, I think. Hasn't failed me yet. But now that I look at this as a shape mod of a 4-layer tetrahedron, a tetrahedral puzzle, it goes so much better. Now that I know what platonic solid this is based on. And the geometry just makes more sense. No more doing Skewb and dyno moves, it's all just center and corner moves. Oop. Don't want to accidentally solve it. Okay, fair enough. So what we're going to do, in line with our concept of the definition of why this is the purest next up version, is we're going to reduce this to this guy over here. So to reduce it, the first thing that we're going to do is we're going to get our centers in. So what we're going to do is we're going to take this, move it in with the green, find the other green, it's here, and just move that in. Okay, so green is here. We can just go ahead and put in the next one. We'll do blue. Everything is next to each other anyway. So I'm going to move this in like so. Get this out of the way, find the other blue, and that's right here. Now we just have 2 more to go. So the way that this is going to work is, not really sure what center goes where, but we can actually try to coordinate it. But we can just kind of randomly put it in. I want this orange to yellow rather to go in this spot and then get substituted with this. I'm going to move it in, which did take this out, but no worries. I'm simply going to move this back and move it out. I'm going to do the same thing. I'll move this in and bump the other yellow one out, put the red one in its spot, and move this back. Okay, so we have center reduction, but we don't know if we have parity or not, because we don't have a guidance regarding the middle space, regarding the middle piece as to where things are supposed to go. So now we're going to coordinate this with the corners, just like we have with the corner here. Let's get our green side in. Turn this over here and turn this in. Okay, now we see what our centers are doing. So this is wrong over here, this is wrong over here. So do we like this? Well, if we swap these two, this will be in, but this green will be in, but the red will be wrong. These two will also be wrong. So the way that we swap these two is we go 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. Okay, so once again, these two are correct, and these two are not. I might have moved the wrong one in. So once again, blue is going to go here. I think I might have done that wrong. So turn it in, move it out, turn it back. Put this in here, put this blue one in, turn, bring it back. Then the final blue one, turned it in, substitute it, bring it back. Okay, let's see if that did the trick. So move this over to here. Alright, so all these are in. Move this over to here. As we can see, all the centers are where they need to be. So we know that we've taken potential parity out. So now what we're going to do is we're going to do edge reduction. So with edge reduction, we're going to reduce this a lot like the way we reduce a 4x4 edge. So we're going to see, basically what we're going to do is we're going to move the correct edge to pair with this, substitute it with this edge, and move the slice back. So we're going to be moving this slice in. So here's a blue and red. Find the other blue and red and move it to here. And that's going to be right over here. So you can see that this is the wrong space. It's got to be turned upside down. So turn it. Move it across here, turn it in. So this is intuitive. If it's not, it should be. What we're going to do is we're going to move this into here, and then we're going to 3-cycle these 3. And by going down, down, up, up, it'll take this and put this into this position. So what I want to do is I want to move the proper blue and yellow here, and you can see this over here. This is the right position because when this comes up, this will be on this side, and when this is knocked out and I move it back, it'll come back on this side. So the way that's going to work is this is positioned here. Move this in to reduce this, and starting with this side, go down, down, up, up, and then when we move this back, this will be reduced. Alright, so now we keep following suit with that. How about the green and red? Find the green and red right over here. So we have to move it to this side here. So this will come over to here. It's going to bat out the blue and green. So let's find the blue and green. Here's a blue and green, but you can see it's in the wrong space. This needs to be up here, because if I put it up here, it'll bat out the same blue and green. Don't want to do that. So this will come to here to pair with it. This will be batted out. When I bring it back, it'll pair with this. So what I'm going to do is move this to the side, and then bring this back down again here. So now this is where it needs to be to come over to here. So bring it down, 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 up, up, and bring it back. Okay, so this is reduced. We're down to the last two, and actually we really wanted to get it down to the last three, but if that doesn't happen, that's okay. Take this, bat this out of the way, and get this one out so that I'll have three that aren't, that need to be blasted in. Now, alternatively, I could do an algorithm to move it in, but we'll do it this way. So down, 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 up, up, and back up. Okay, now this can come back to here, but I'm going to want to turn this upside down. So this will come down, across, and then back. So now this will move up to here, down, 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 up, up, and back. Okay, so the puzzle is now reduced to just a James Pyraminx, or a three-layer tetrahedron, as they call it. So now let's go ahead and do the solve exactly the same way. We'll start off with the corners. So here's green and red. Find the other green and red. That's not this. This will go over to here. The other green and red is here. Okay, so these are all in. Now we're going to just put in the edges. So this is a green and yellow. It goes over to here. Move this out of the way. Bring this corner down. Move it into place. Move it up. So this is in. This is the green and red. So we bring this down. Move it in. Bring it up. So this is in place. Leaving us with one more. This is upside down. So let's just move it down. Get it out of the way, move this back up, and now we can come down from the other angle and up. Okay, once we've done this, we come over to here and we match the corners to here. So this is already matched up. And then we take a look at these edges and see what we've got. There's a couple of possibilities, and there is the possibility of parity. So this doesn't belong here. This belongs over where the red one is. Yellow and red. This belongs here, this belongs here, this belongs here. So basically we have to turn, we have to three-cycle these. We can do our algorithm, we can do our SUNY by doing R, U, RI, U, R, U, RI, and it's solved. Now that was the simplest possibility, but let's go through some other possibilities that you're probably going to get with this, because you will potentially get parity with this. So this situation here is not something that you've seen in this. Now you've had it where both of these are upside down, and if they're both upside down, then you can do that algorithm that I'd shown, or that strategy that I showed. Here you have this needs to go to here and this needs to go to here. So that's a single swap, which you're not going to be able to get. You're not going to be able to get with this. So it's a true parity of reduction. So in order to get this in, we're going to be utilizing that algorithm that I showed to sort of cycle these around. So the way to look at this is this needs to get into this space over here. And what you can do first to get this to here is we can turn this to here so it can be ready to do the algorithm. And then we can turn this to here. This will go here, this will go here, and this will go here. So we can start building these back in. So it's going to be up, down, down, up, down, down, up, up. Now these are non-overlapping areas, so it doesn't matter what order you put them in, but we're going to move this back into here and move this back into here. Okay, so what you're going to see is this is in, so that's good. Now we need to three-cycle this to here, this to here, and this to here. And the way that's going to work is first thing to do is let's put this into our ready position here. And now we have to put these two close to each other. So I'm going to move this, I'm going to do a B move like this. I guess that's a BI right here. So these two are going to participate in the algorithm. So what I need to do is I need to move this like so. Boom. So it's a BI and a UI. So to get out of it, I do a U and a B. Now to get this, I need to move this to here, so I'm going to do the algorithm twice. So basically what I did is to get it into position next. As I move this into place, then I'm just going to do BI UI. And go ahead and do that algorithm twice. Up, down, down, up, down, down, up, up. Do it again. Up, down, down, up, down, down, up, up. So let's reverse what we did. We did a UI, so we're going to do a U and a B. And now remember, this has to move back as well. Put this into here, and now all these are in. You've already dealt with the centers, so you can do a 2 swap with this, where you hold it here and do 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, and done. So a nice, a little challenging step forward with the 3 layer. The 4 layer does give you the even layer parities. Remember, this is just the derivative of the 5 layer. But now the contention is, how can I use those strategies to solve the F-Skewb? Okay, so now we're going to compare this to the solve of the F-Skewb. You can see it's in the solved position now. What I wanted to do is go over a quick algorithm. We're going to solve it just like the 4-layer tetrahedron. But it's a little different because notice that these centers have equivalency of color. These do not. So these have more diversity of colors. So basically they're different colored pieces, which means this can be in any old way. This is in a very specific way. So from time to time we may have to do an algorithm. Now the trade-off is that these have specificity also, but these do not. So they're the same color, whereas these are the same color. So the algorithm to bear in mind is one which moves these edges around. Well, yeah, I guess we can call them edges, and these centers around, although they're corners over here. So these represent the corners of this puzzle, and these represents, well, actually, I'm sorry, these represent the centers of this puzzle, and these represent the corners of this puzzle. And well, they can be solved the same way. But basically, the algorithm that you're going to do, which is going to be very similar to exactly the same that we did with the master Skewb here, is this. Well, this will go to here. Well, let's do this first. We'll cycle these around. The way this is going to work is, with this held with the corner facing us, is this piece will go to here, this will go to here, and this will go to here. And the way this is going to work is you're going to do a middle slice up, then with this corner here, you're going to go down, down, up, and then this middle slice goes down, and finish it up with a down, up, up. So that took this yellow, put it here, this green, put it here, this red, and put it here. So that's when we have to use that in a pinch. So let's do it again. Up, down, down, up, down, down, up, up. So you can see one more. We'll put this green here, this red here, and this orange to here. Up, down, down, up, and down, down, up, up. Okay. There's a specific reason why we needed to use that algorithm. It's the same algorithm that we'd used here that I showed, which moved this to here, this to here, and this to here. So that's when you had an issue with the rotation of these centers, these edges rather. The other algorithm is how to move these center pieces around. And what this algorithm is going to do is it's going to take this piece move to here, this to here, and this back down to here. It's going to 3-cycle these. And the way that you're going to do that is you're going to take do a middle move like this, so we're going to call that down, and then we're going to do down. This is going to be Skewb move, down. This is going to be center move, yeah, center move, down, up, and then we're going to go up, and then down, up, up. Now it did move these guys around, but don't worry about that. It did take this yellow and green, moved it here, this blue and white, moved it here, and this white and green and moved it here. So it's going to do those maneuvers. Don't worry about these, that gets fixed later. So once again, if we want to move this to here, and this to here, we do a middle slice down. And notice this is going to be an entire center move, down. This is going to be a corner move, down, center move, up. Then this moves up, and then reverse it, down, up, up. One more should get these back. Down, 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 up, and up, down, up, up. And it made it go back. Okay, so that's the only algorithm you're going to need to know, and you're going to need to know that because you have slightly more complexity when it comes to this. So let's go ahead and scramble this up and see what is a way to solve this as a modification of a 4-layer tetrahedron, which we're going to call, as these tetrahedrons are the base puzzles. It's going to be with exactly the same strategy, with a little bit of complexity because of the specificity of center rotation. Alright, I don't want to short sell myself in terms of the challenge here. So let's get it all messed up and no place to go. Okay, that looks pretty good. That looks pretty separated in terms of its pieces here. Okay, so there you have it. So the first thing to do is I want to reduce the centers. Now to reduce the centers, I don't have a centerpiece here to guide me what color goes where. So I'm going to kind of need to know the 3 colors of each corner, because I could be fooled and actually put a piece that doesn't belong. So what I would do is, just like we oriented these corners to decide where these centers are going to go, we're going to orient these corners as well. So here's a green. Where's the other green? The other green is right here. So let's turn these greens next to each other. So I'm just aligning the corners. This is equivalent to aligning these corners here. So this goes here. This is the centerpiece, so it's going to be around here. So notice that this is already aligned and this is already aligned. And I can turn this piece down here and align this corner. So all of these corners are in, but I want to define what is this centerpiece, and it's going to be the red, yellow, and green. So now that I know that that's the case, that's what I'm going to put in here. So here's the yellow and green and yellow and red. So this happens to have that, I just need to put in the red and green. So find the red and green, it's right over here. So now as I move this, I'm going to take these corners out, but I'm not going to care about that. Because now that I have this coordinated here, like so, I've got the red, yellow, and green. So now I know what colors go where. Next is going to be this green, green and white. So this green belongs here. To move that in, I'm just going to bump this out of the way. Turn this in place, bump it back. Okay, so I've got the 2 greens here. What I'm looking for is the white and yellow, white and orange. So white and orange, find it right over here. So as I move this, it shouldn't coincide with this guy here. It shouldn't mess that up. This is going to move into here. That's going to mess this up, right? If I move this here, this here. So what I'm going to do is, let's move this out of the way. We'll move this down, like so. Move this where I want it to be, move it up. So now these 2 are in. So I've got these 2 correct. Now I needed the corners to tell me what colors go where, because I might have put the wrong color in the wrong place. It's certainly possible, because I might have matched up this green and yellow with this this green and orange with this green and yellow. And I might have been looking for the wrong yellow piece, orange piece rather. Okay, so now we look at these 2 centers. This center here and this center here, and we just have to roll them in. But in terms of what direction do they need to go? Well, we don't really know yet, but at least we know what colors belong where. So if this is an orange, this is orange. If we were to line these up, this is orange, it's going to have the orange and the yellow, right? So if you can imagine this center, if it's in between these 2, yellow and orange. So that's what we're going to look for. Here's orange and yellow over here. And the other color is going to be blue, because because that's opposite the green here. Okay, so yellow and orange and blue. So I'm going to move this to here, and I want to move this into position. So I'm going to move it in, bump this out of the way, move this back. All right, so far so good. I need the orange and blue, yellow and blue rather, it's going to be right here. So I'm going to move this into place here, so this matches up this white, turn this into position, and move it back. Okay, so all these centers appear to be reduced. The next step would be normally to reduce the edges, which are these guys, but this is very important. Before I do that, I have to make sure that these corners are in the right place. Because if they're not, then I have to start swapping corners. If these centers are in the right place. So what I'm going to do is let's put our corners back in again. So these two match up. This has to match up with the red. So I'm only doing these Skewb moves here. And so this is the center here. We'll get this center to this corner to line up with this. So all these are now in. So let's take a look at our centers. Our center should either be in the right place, or it should be able to be swapped to the right place with its complementary piece. So here's a green, red, and yellow, and this is going to belong right over here. So this belongs over here. Now notice that it's not there, and it's okay if it's not there, if its complementary piece, the place that it's in, is where this is supposed to be. So if this is supposed to be here, the piece that's supposed to be here should be up here, so they can swap. And you can see that that's not the case. So if I swap these two, this will be in, which is correct, and this will be over here, which is not correct. And if only one is correct, then none are going to be correct. So does that make sense? In other words, this center belongs here. So in order to get it here, either it's there or it's not, and if it's not, I've got to swap it. If I have to swap it, then what I'm swapping it to, where I'm swapping it from, should be this piece. So this needs to be able to be the one to swap to this area. If it's not, then this isn't going to be in. So wherever this is, it has to swap with the piece that belongs here if this doesn't belong here. So what that tells me is that this green, the other green, the green, orange, and white, which is right here, this actually belongs over here. Thanks, Evan. All right, so without any further ado, I'm going to do that. Now, once I put this to here, this one edge center to here, the rest should be where it needs to be. So I'm just going to roll them in. So I'm going to move this in here, move this in, substitute this, bring this out. Now this is going to come in here, this comes in here, turn and turn. And now this needs to come up to here. So down, turn, and up. Okay, so now we take a look and make sure that everything makes sense. So let's move these back in, like so. Okay, so what we see here is this green, white, and orange is where it needs to be, and this green, red, and yellow is where it needs to be. So now these are matched up fine. We take a look at the other centers, and we can see that this is not where it's supposed to be, and this is not where it's supposed to be. It's not even correct. So this needs to be flip-flopped with this over here. This isn't even in correctly, so let's start moving things in. This blue, red, and white to here. So I'm going to move them in one by one. First move this one in, turn this, and move it back out. Now this has to come into here, so let's move this down, turn, and move this up. Okay, now the final one that we have to do is we have to move this one in, but let's see if we can match this center. So I need to move this up to here, but let's take this blue and yellow and match it down here so this blue matches to this blue. So I'm aligning this to here, turning, moving it in. And in so doing, this is in and this is in. So now I could look at my centers, I could try to get it back, but I can have faith that it's really where it needs to be. But just for the sake of argument, let's line up our corners here. This is good, this is good, this is good. And these are all good here too. Okay, so let's see what needs to go where. In terms of the green, this green, yellow needs to come into here. So this needs to come into here, and it's in the spot of the blue, red, and white, and that's this. So if these two swap, they'll be exactly where they need to be, and we can probably say the same thing with this. Okay, so that's all we needed to do. So what you want to do is get your edges in first. It's real simple. Find out the color scheme of your first center. From that, you can put in your other centers. Then line up your corners again and see if the centers are where they need to be, and if they're not where they need to be, can they be evenly exchanged with the piece that belongs where it's at. So either this is in, or if it's not in, it can be evenly exchanged with the one that belongs there. If it does not exchange with the piece that belongs there, this may be in, but this will still be out, and it won't be solved. Okay, so this is coordinated. Now that we've done that, we can put in the centers. We can put in the edges, and this is really easy. It's just like we did with this over here. So we're going to take this, say over here, and we can see that this white one is going to match into this if I do a slice move. The exchange that we're going to do is this, this, and this. Just like we did this, this, and this. These edges are similarly going to exchange. So when this is bumped out, I'm going to have to move a blue one in to match with this one when it moves back. So where's the blue? Here's the blue over here. So let's move this in. But bear in mind, when I knock this out like that, this blue is going to move back into this spot. If I move this back in, this is going to knock it out. So this blue has to be up here. It's got to face this so that when this is moved up here, this blue will be in this spot here. Okay, so how am I going to turn this around? Well, let's move it out of the way. Move it up like this. So just kind of think about that intuitively. I moved it down and then use the Skewb move to move it back up here. Just get it back up here. So this white will come into here. So middle slice it down here. Then with this, starting with this piece here, go down, down, up, up, and Skewb it back. So now you've reduced two. And we keep going with this. So here's a red. This red belongs here. And this yellow is going to move out. This would be upside down. So let's move it out here, Skewb it back up here, and now it's in the right place. So move it up, down, down, up, up, and move it back. Okay, in that way we now have two left. We really needed three left. So let's move this into this spot over here. And I have to move a third one out. So let's do it upside down because I want a green to move into where green is. So let's move this here. Okay, this will move to here and exchange with this. So green, bumping it out for another green to keep this out. Down, down, up, up, and move it back in. So now I have three that are out. I want to move this back in, but I want to match it up with the green. This is upside down, so Skewb it here, Skewb it again, and then move it up from this angle. So now you're fine. So down, 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 up, up, middle move it back, and done. So actually, this configuration is the same configuration as all the centers reduced and all the edges reduced. We dealt with issues with parity that had to do with not knowing where the centers were, and now we just solve it as we would a tetrahedron. So what we did is, let's first get our corners in. We're going to get our first side. So we're going to get corners of our first side. So let's start off with the green. Okay, green, and our first side is going to be just like this, and that's already in. It won't be hard, it's probably going to automatically be in. So this is the center, and we've got to place the edges. So the first edge is going to be the green edge, and this is that bottom layer. So here's the green over here. So what we're going to do is move this down to this layer, this edge, move this in, this edge over here, this corner rather, and then move it back up. So this is matched up. We go to the next one, which is white. White is down here. Move this edge here, move this edge in, bring it up, and now this is done. Finally we do the yellow, or the orange rather, orange is here. So move the orange down, move it in place, bring it up. Okay, so what you have is you have the first side, the equivalent of this with the center out. This is the center and it's out. Once you've done that, we turn it upside down, and we want to move the edges in to the opposite layer. So turn it upside down. Let's move this in place. And now we have an interesting bit of parity here, because this is in, but these aren't. So we saw that kind of parity before with this when two had to be flip-flopped. So these two have to be exchanged. And the question is, how are we going to do it? And the answer is pretty much the same way we did this. So we're going to be doing that corner, that edge swapping algorithm. So we'd like to move this red into here, this blue into here, and this, this red into here, this blue here, and this is out as well. So the first thing that we want to do is let's go ahead and move this red where it needs to be here. But I don't want this to participate in the algorithm. So I'm going to move this like so. So these two will participate. Then I'm going to move this, well, over to here. This red will go here, this blue will go here, this red will go here. So it's going to be up, then down, down, up, then down, and down, up, up. Okay, so what we want to do is we'll just kind of get it back to get our orientation. And these two move independently, so they're not going to destroy each other. So this will move back into here, and this will go over here. Okay, so we take a look at what we did. We're exchanging these. This is where it needs to be, and this is where it needs to be. Now I just got to move this to here, and this has to. We have to do a 3 cycle with this. So we had a way of moving these things, because we want this red to go here, this blue to go here, and this blue to go down to here. So that this is going to work is that we're going to do a D to move this here, and then a U to move this here. Okay? Now what we're going to do is we're going to take this, and I want it to exchange with this guy over here, so we're going to move this center over here. It's the same pattern that we did, so just remember we did a D and a U over here. So this will go up, then down, down, up, and down, down, up, up. Okay, fair enough. We can move this back. You can sort of match where we went over here. And now we're going to do a UI, which will move this to here, and then a DI, which will move this to here. Okay, so in that way, you did exchange these over here. Okay, and what's more, we didn't take these edges out. All right, now that we have that, and again, you can rewind that, watch that closely. It's really the same thing that we did over here, just a matter of positioning. So now we look at the centers, and we're just going to roll the centers in. And if we did this right, there should be a symmetry with this. Okay, so this belongs here, and this belongs here. So we've seen this before. So we're going to go ahead and move this in by doing our center exchange. It's going to be the same move as this. Let's try that again. Same move as this. If I exchange these, this goes here, down and back. So same thing with this. This is going to go up here. Oh, let's be sure what we're doing here. That's right. Right here. Okay. So it's going to be 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. Okay. So what you can see is these are in the right place, but they're rotated wrong, and these have actually been fixed. So what we want to do, how do we get these correctly placed? And the way that we're going to do that is we can see that this has to rotate clockwise, counterclockwise. So that's what we're going to do, is I'm going to take this piece and I'm just going to rotate it like this, boom. Then I'm going to exchange these, and after I exchange it, I'm going to rotate it back and then replace it back in again. So now that I've rotated this where I want it to be, like this, we're going to exchange these two centers. So it's 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. Now we rotate this back. We did a UI, so I'm going to go U, and we simply rotate this back. 1, 1, 1, 1, haha, 2, 2, 2, 2, 3, 3, 3, 3, and the puzzle is done. However, there is a kind of a parity that you might get with this, which looks, well, a little something like this. Okay, something like this, where you've done everything right, but now you see this situation, this thing is rotated, which normally wouldn't bother us if another one was rotated. If you've got two that are rotated, no problem, like we had. Even if two are in, if you have two that are rotated, you can deal with that. If it's just one, well, you've got some parity. So how do we get out of this? Well, we're going to get out of this by using the algorithm of how to flip these, because it's pretty easy to 3-cycle these puzzles, these pieces rather. So what I really want to do is I want to take this piece here, and I want this piece to move over to here. That's what I want to have happen. So what I'm going to do is this piece needs to go to here. So if I move this to here, and I do that algorithm twice, this will move to here, this will move to here, and this will move to here. So if I do it twice, this will end up over to here, which is what we want. When you think about it, this will end up here, which is also what we want. So let's do that algorithm 2 times. So we've got down, 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 up, and then up, down, up, up. Now if we do it again, this will be where it needs to be here, this will be here, and this will slide over to here. So we'll do it twice. So middle slice down, we do a face slice here, down, corner slice here, down, face slice up, then move it up, then down, up, up. Okay, having done that, I then turn this back where it was, and you can see this is now rotated where it needs to be. And these 3 pieces are out. Well, that's okay. All we need to do is 3-cycle these. We find what direction that's going to be. So this will go to here, this will go to here, this will go to here. And all we have to do is turn this in this direction here. Boom. This to here, this to here, this to here. And one more algorithm, we'll be able to get them back. So up, down, down, up, and down, down, up, up. We turn this back, and done! Your F-Skewb is now solved, and I think it was solved in a much more intuitive and easier way for me to follow anyway, if I treated it as a tetrahedron, rather than doing a lot of confusing maneuvers to look at it like a Skewb. Just look at it as a shape mod of a tetrahedron. We just had to deal with the specificity of the centers. We had to make sure that we were coordinated with the corners, and then we knew how to do the proper swapping. And then at the end, to use these algorithms to just pick up the pieces here. So there you have it. Now we can finally know what the F-Skewb is based on. The F-Skewb is really a shape modification of a 4-layer tetrahedron, which is the twisty puzzle platonic solid of the triangular of the tetrahedrons. So where I'm going to leave you with next is what we're going to do is proceed from here. Put this in its respective place here. Put this on camera. Whoop. Where we're going to go next is in solving this. We're going to correlate that with the solve of the master Skewb, which is really a shape modification of the tetrahedron. what I would encourage you to do is, after solving this, do this like a master tetrahedron, and the question is this going to be a better solve, a faster solve, a more efficient solve, or a more fun solve than the way that we've been doing it? And even if it isn't, it's still fun to solve it in an alternative way. Otherwise, these puzzles just sit on the shelf, and you're so tired of doing it the same way. Anyway, that's next up, and thanks for watching.